Gravitational aberration, sometimes called retardation, refers to the fact that in relativity, gravity propagates at the speed of light. And just as light takes 8.5 minutes to reach us from the sun, gravity would take the same amount of time. Since the sun is moving around the galaxy, Earth would orbit the location where the sun was 8.5 minutes ago. The rest of the planets and asteroids in the solar system would also experience a delay proportional to their distance from the sun. The effect is illustrated in this animation. This is the sun's gravitational well. Only a cross-section of the well is shown for clarity. By the time light and gravity reach our planet, the sun has moved to a new position. The result is that the gravitational well is not symmetrical. This effect could be a serious problem for stable orbits. Let's look at the case of the moon orbiting Earth. By the time the moon returns to a given position 1 month later, Earth has changed direction of motion by 30 degrees as it moves around the sun. For objects farther away from the sun, the delay could be much greater. For example, the Oort cloud is estimated to extend more than 1 light-year from the sun. Scientists have known for some time that the planets orbit the instantaneous position of the sun, regardless of their distance. This would require that the speed of gravity be 10 billion times faster than the speed of light, or higher by some estimates. Recent observations of a merger between 2 neutron stars in August 2017 have confirmed that the speed of propagation of gravity is the same as the speed of light in a vacuum. This problem is easily resolved by having the sun be stationary in a gravitational bubble. When we look at Saturn, we aim our telescopes to the position where Saturn was over an hour ago, since it takes more than 1 hour for the light from Saturn to get to Earth. When we see Saturn, Saturn is no longer there. Let's suppose that Saturn were not moving, and it were always in the same position. If that were the case, we would see Saturn in its present location, even though light takes more than 1 hour to get to us. When the sun creates a gravitational bubble around itself, the sun is always at the center of the bubble. Space falls towards the sun within the bubble, and the sun's gravity propagates through the space in the bubble. Planets orbiting the sun within the sun's bubble will see the sun always in the same position, because the sun is not moving through space. The sun's bubble is moving through space around the galaxy, carrying the planets, asteroids, comets, and all other objects orbiting the sun. This animation illustrates the effect. The planets also create smaller gravitational bubbles around themselves for their respective orbiting satellites. The planets are also stationary with respect to their own bubble. It is the planetary bubble that orbits the sun.